Hello dear members, welcome to this discussion, and tonight we are going to do a number of questions on AC machines. So we are beginning with one on single phase transformers. So the question says, in a 25 kVA 2000 stroke 200 volts single phase transformer, the iron and full load copper losses are 350 watts and 400 watts respectively. Calculate the efficiency on full load unity power factor and B half full load 0.9 power factor. So let's right away begin this problem. Now, the data that we have the kVA rating, which is 25 times, let us convert it to VA, so let it be power 3 VA. Then we have the E1 equals 2000 volts, and E2, which is the voltage rating of the secondary windings, is 200 volts. Then we are also told that the iron losses are 350, so let us call it PI to be 350 watts. And also the copper losses, P copper, is equal to 400 watts. So now, if we are talking about full load and unity power factor, so part B, we are talking about power factor equal to 1 and full load. So that means the transformer is operating at unity power factor and full load. So if we are talking about the percentage of load, usually we call it X. And so at full load, X is equal to 1. In other words, the fraction of the load that is connected to the transformer. So efficiency, usually percentage efficiency, is always equal to the kVA rating times the power factor divided by the kVA rating times power factor plus losses times 100. What are we doing here? We are saying this is power output divided by power in times 100. That gives us the efficiency of the transformer. So what does that tell us? So let us substitute in the values that we have. The percentage efficiency will therefore equal to 25 times 10 power 3. We are multiplying by 1, of course, as the unit power factor, divided by 25 exponent 3 times 1, then plus losses. Losses will have iron losses, which are equivalent to 350, plus 400. So we shall multiply by 1 squared, okay, times the copper loss. And the copper loss is equal to 400 watts. So everything times 100. So now if, for example, anyway, we shall see that condition in the next part of this question, where x is not equal to 1, but is equal to a half. So it will be x squared times 400, and we shall substitute in the value for x. So that efficiency will equal to, let's compute. So we are getting our answer equivalent to 0.97087 times 100, and this is going to give us 97.09%. So that is the efficiency of this transformer while operating at full load and unity power factor. So part B, for the power factor equal to 0.9 and the load actually operating at half load. So meaning X is equal to 0.5. So for that matter, efficiency will equal to power output divided by power in times 100. So but what is power in? Power in is equal to power out, of course, plus loss. But what are the losses? The losses are the Pi plus the PCU or P copper. But this P copper is having a coefficient of X squared. Now X represents the proportion or the portion of the load connected to the transformer. So this is going to be 350 and losses are constant, whereas copper losses depend on the load. So we have 0.5 squared times 400. So let's first compute that. 350 plus 0.5 squared times 400. So we are getting this as 450 watts. So what about the power out? Power output is going to be the kVA rating times the power factor times the fraction of the load. So this is 25 times 10 power 3 times the power factor, which is 0.9 times 0.5. So 25 exponent 3 times 0.9 times 0.5. So I have 1125 0 watts. So efficiency, therefore percentage efficiency will be 11250 divided by 11250 plus 450 and times 100. This is giving us 96.15%. So that's the efficiency of this transformer while operating at a power factor 0.9 and half full load. What if a question wanted the efficiency at maximum, let me say, okay, the portion of the at maximum efficiency. So the portion of the load, we know this formula is proven that at maximum efficiency, then we have the fact that X squared PCU is actually equal to Pi. In other words, the copper losses are going to be equivalent to the iron losses. So therefore, the portion of the load will equal to Pi, okay, divided by PCU power a half. So this is going to be, we know the copper losses, the iron losses are 350 divided by 4,000, everything under root. So that portion of the load will be 350 divided by 4,000. We are taking root of the answer. So for this transformer, at X is equal to 0.935, the transformer will be having maximum efficiency. So if they ask you the rating of the transformer at that point when it is operating at maximum efficiency, so the kVA rating at maximum efficiency will equal to X times the kVA that you have above there. So this is going to be 0.935 times 25 kVA. So times 25 kVA. So here I'll have 23.39 kVA. So that is the rating, is equal to the rating of the transformer at maximum. So thank you for tuning in. See you in the next